In this way, we are here again for the protocols governing the web. First of all, we need to understand what are the protocols is all about. Protocols is nothing but set of rules. What are things follow? First of all, have a little bit understanding what really the protocol is. Then we move forward this in the deep manual study of each and every protocol. A protocol is a set of rules, and protocols allows two computers to communicate over media such as wireless or hardware technologies. Okay. So, and this protocols are in a stack actually. Stack is just a have you ever seen the loaf of the breads and it's standing vertically? So they are in a stack. So protocol stack, when computers communicate with each other, there needs to be common set of rules and instructions, to be followed. So what are the common stack of the thing? What are the stack protocols or the language of computer and how does the stack work? See, here we have optical fibers, twisted pairs coaxial. These are the hardware things, and then it is connected with the PPP protocol and Ethernet. It is connected with the IPv4. This Internet protocol. And Internet protocol is then transferred through TCP or UDP, and this is reflected on the web screen. To the web domain with the help of the SMTP. SMTP helps us to understanding the transferring of the mails. Then there is for UDP we have RTP, and for HTTP it's usually we use Firefox, Silverlight. These are the web browsers. For SMTP we have a Thunderbird. For UDP we have MPLR. And this sometime of protocols is modeled in the TCP/IP model. For the protocol to make an stack, we model the things. Right now we're taking an example of the TCP/IP. First of all, look about the things. For the network interface, we have an Ethernet protocol. For the internet, we have an Internet protocol. For the transport, we have a TCP/UDP. And for the application, we have HTTP for the web and POP3 for the email. Let's have a simple understanding of what this protocol is all about. Hypertext transfer protocol. This protocol is used to access, send, and receive hypertext markup language HTML files on the internet. Simple mail transfer protocol. This is HTTP. Let's move towards the SMTP. Simple mail transfer protocol is used to transfer the email in the computers. What is the file transfer protocol? File transfer protocols uploads on the server and download files from the servers. So FTP is used for the upload on the server and download on the server. What are the TCP? This protocol ensures the delivery of information packets across the network. What TCP do? This protocol ensures the delivery of the information packets across the network. What is the Internet protocol? This protocol is responsible logical addressing called IP address to route information between networks. So these are the little bit an example of the protocol. Let's have a clear understanding about really the deep understanding about how this TCP/IP and all these functionalities works in deep manner. See, let's understand this topic: protocols governing the web. The protocols governing the web is needed in order to make the internet domain to function well. The protocol is simply a standards which enable the connections, communication, and data transfer between two places easy. Here are some key protocols in which we need to discuss to understand the web, and how the data is transferred through the over the internet. So first and foremost protocol is TCP. TCP protocol, the full form of the TCP protocol is a transmission control protocol. It is a standard how to stabilize and maintain a network conversation where which application program can exchange data. Okay, TCP works with the IP, Internet protocol, which defines how computers send packets from to each other. See, when we write hi, how are you, on a system through a messenger, instant messenger, any instant messenger, that instant messenger's job is just to take this and as a alphanumeric, and alphanumeric will be changed into 0 1 into the digital formulation, and that digital formulation is modulated, and then it is modulated in 0 1 form, and finally with the help of this stack algorithm, the stack of the protocols, we used to send from the sender to receiver. Now let's move ahead. Together, TCP and IP are the basic rules defining the internet. TCP and IP are the basic rules defining the internet. Okay. TCP is a connection-oriented protocol, which means a connection is stabilized and maintained until the application program at each end has finished exchanging information. So, before sending a message from our sender to receiver, receiver to sender, we used to have in a protocol. We used to have in a protocol from which we have in a message box on which message was going to write message transfer from from host to server, and the server transfers to the receiver. Okay, and in this process, a connection is stabilized, and its connection is stabilized and maintained until the application program at each other finished exchanging messages. Let's move ahead. See what TCP in when TCP is working. What are the things TCP used to carry? First of all, our data. Hi, how are you? And its option padding according to the network requirement. Then it's add checksum for urgent pointers for understanding at the receiver end, because data is going to the 0, 1, and then we have a sliding window size according to the network configuration, and where the header length reserved ERG acknowledgement PSN right synchronization finishes there, and then we have acknowledgement made, then we have a sequence number, then we have a source port and destination port. So this data is divided into the various different forms, and that forms has been padded with the information of the network, and finally at the source end, when it is acknowledged, the data is received, that is arranged with the sequence number, and finally the source port and the destination and source port and destination port understand what has been sent from the sender side. To understand more deeply, at the data link we have a header, internet protocol, TCP, application data, footer. At the internet layer we have an internet protocol, TCP, application data. At the transport layer we have a TCP and application data. And application layer we have an application data what we have sent. So these works together. These IP, the next protocol works together with TCP. So what the IP is all about? IP protocol provides the packet delivery service. To send data from host to receiver, we need a packets delivery. So this packet delivery services for TCP, UDP, and Is Udp. The IP layer protocol is unreliable, called the best effort protocol. There is no guarantee that IP packets arrive, or that they arrive only once and are error-free. Such reliability is built into the TCP protocol but not into the UDP protocol. If you need reliable transport between two UDP publications, you must ensure the reliability is built onto the UDP application. So TCP is mainly a connection oriented and UDP is mainly connectionless, but with some application changes within the UDP methodology, we can make it connection oriented as well. So in the internet protocol, it is a method to send the data from one computer to another computer, and each computer, which is known as the host on the internet, has at least one IP address, and that uniquely defines from all the computers available on the internet. So, and this communication protocol works on the wide area network and local area network as well. Now, moving ahead. The Internet Protocol is a part of the TCP IP protocol suite, and terms IP network and TCP IP networks are synonyms actually. And what technologies uses? It uses the packet switching. The packet switching IP uses a packet switch architecture in which data is broken into the smaller packets, which with each packet containing a source address and destination address. IP packets are handed over to the data link layer, such as the Ethernet, for the actual physical transmission to the next node in the network path. IP is the network layer. Well, IP refers to the entire TCP IP protocol suite. The term IP layer refers to just the network to network part, occupying 3 layers in the protocol stack. To learn to really understand about the IP networking, one should understand about the OSI model. Well, so this OSI model is used to what we can say, philosophically it is used, but practically TCP/IP is used. Philosophically, why it is used to define the sending of the data from the host to receiver. First of all, we need to have a network physical layer and data link layer, which is jointly called as a network interface layer. And next, it is a network layer. And next, it is a transport layer. And next, we have a session layer, presentation layer, and application layer, and this is combined and called as the application layer in TCP/IP. So this 1, 2, 3, 4, 5, 6, 7, 7 layers is converted to 1, 2, 3, 4, 4 layers in TCP/IP protocol suite. And this is a TCP/IP protocol suite. In the network interface layer, we have an Ethernet, token ring, other link layers. For the network layer, we use IP. For the transport layer, we use TCP and UDP. For the application layer, we have HTTP, FTP, Telnet, SNTP, and DNS. Let's move. Let's understand something better. When any network of the network user is there, first of all, he uses application layer. At the application layer, he uses some email, file transfer, client server. So, and then at the presentation layer, we have encryption. See, this communication, email, and transfer client server. This client server is encrypted data conversion from SCI to EB, CDIC, BC to binary, etc. is done. What I have said to you that if you write hi, how are you, it will convert to the UNIT. Then at the session layer, we have a start-stop session, which maintains the order. Then at the transport layer, we ensure delivery of the entire file or message. And at the network layer, we route data to different lines and bands based on the network address. Next, we have a data link MAC layer, transferring packets from node to node based on the station address. Then we have a physical layer, electrical signals and camera. Okay. For this, with this TCP/IP analogies here, we are using IP first of all, ICMP, IGMR, AGMP, RP, RARP protocol for the network layer, TCP, UDP for transport layer, and this for session presentation application we have FTP, Telnet, HTTP, SNMP, DNS, FRP, ping, tracer. These are the protocols used in the TCP model. And this is for your understanding, and this is actually what is working behind the your application area. So what is the TCP/IP protocol? So conceptually, the TCP/IP protocol stack consists of 4 layers, each layer consisting of 1 or more protocols. A protocol is a set of rules or standards that 2 entities must follow. To allow each other to receive and to interpret messages into them. Entities could be, for example, be 2 application programs in application program, and entities might be 2 TCP/IP layers in the 2 different IP hosts. TCP/IP is the set of communication protocol used for the internet and other similar networks, named from 2 important protocols, TCP and IP. TCP, the transmission control protocol responsible for the data delivery. IP, the internet protocol responsible for the breaking the data into packets. So, major the work of the TCP is data delivery, and what is the IP? What IP do? IP actually breaks data into packets, and how it is working. See this. See here. Again, this is just an analogy. I'm making a device again and again from from which we are able to understand it in a more better manner, because this is a base ground for our protocol. Hello. So this we are able to understand the network access. The Ethernet, token ring, SNAP, FDDI, SDN, frame relay, wireless, fiber channel, cable modem. This all works as the network access, data link layer access. For network layer, we have IP and ARP. And why ARP is needed to if the message is not reached, one should ensure this. This insurance is taken care of by this protocol. Then the transport layer, we have a TCP, UDP, and ICMP. These are the OSPF. These are the protocols. And a protocol, we need protocols according to the need of time. Okay. At the application layer, we have HTTP, FTP, Telnet, Finger, DNS, POP3, SMTP, POP4, BGS, TANG, LNTP, SSL, SHOX, etc. So, DNS, SMP, IRP, radius, archive, trace route, TCP, kernels, all of this. Ping and trace cards at the application. Let's move ahead. Let's move ahead to understand it better more. See, at our hardware, we connect with with IP, and then IP breaks for supporting this IP. Also, we have a more protocol like ICMP. We direct go to the user process. Then we have ARP and then RARP. If any thing is that which is not for to any end, sometime electric current is not there, so hardware is not working. So ARP protocols was like the operation and the start from yes, no start from start from hardware interface, and then this IP help is TCP IP protocol to user processor, and this IP also using helping the UDP for the user processor, and this IP also helps for the user processor. Let's move. So for helping this IP, we have our ICMP protocol as well, and this is known as the Internet Control Message Protocol. The Internet Control Message Protocol or ICMP provides management and error reporting to help the manage the process of sending data between the computers. And so that's why its major job is of management. This protocol is used to report connection status back to the computers, okay, and trying to connect other computers. For example, it may report a destination is not reachable, very important information, because somehow when we send a message, we understand it is sent. Okay, this ISMP also used to handle error and control information at the IP layer, which help us to make it more effective. And this control application, see this network control application helps the TCP/IP software product itself to make it more viable within the system. And for executing this, we have a command like ping, trace, route. These are the network controlled application, which is the ICMP protocol. We use ping, trace, route. Okay, this how this ICMP works. When a host send IP datagram of TCP IP, and it is IP is the datagram and discarded an ICMP message sent to the host, and within that ICMP message we have a IP header and this ICMP IP header, and this ICMP header converting that type of message is unused, and this original IP header with the 8 byte of payload is the okay. So and for this ICMP error message format is having a 3 representation: a destination, unreachable. Okay. So where code values clarify the type of unreachability as follows: 0 is equal to net unreachable, 1 is equal to host unreachable, 2 is equal to protocol unreachable, 3 is equal to port unreachable, 4 is equal to fragmentation mutate, and DFL is 5 is equal to source fail. So like this things happen. Okay. Let's move ahead at the application layer. The application layer, the first and foremost protocol is FTP. FTP stands for the file transfer protocol. It is used to transfer files. It is used to transfer files across the internet. Okay. FTP stands for the file transfer protocol. It is used to transfer files across the internet. FTP is commonly used by the web developer to publish updates to a website. That is to upload a new version of website or some new data within your website. Where HTTP is used to displaying file in your browser, FTP is simply used to transfer the file from one computer to a specific location of another computer. You can use the FTP to transfer files from your computer or remote computer, such as web server transfer from remote computer or to your computer. Okay. And this is the way how TCP works. Client has a disk. Client take data from the disk, and with this control user with his user interface interact with the control processes, and with the control processes and data transfer process with the help of the TCP IP and the control connection, it sends to the server. And in this process is taken care by file transfer protocol. This data transferation with the control connection of TCP IP is taken care by the file transfer protocol. And finally, data is received toward the control process and data transfer process of the server, which push the data into our disk. Now let's move. What is UDP? So at the network layer, we have IP, and for sending we have two phenomena, TCP and UDP. TCP is connection oriented, UDP is connectionless. So what UDP is all about? UDP stands for the User Datagram Protocol. It is an alternative to communication protocol to TCP, in use primarily for stabilizing low latency loss toleration connection between applications. Both UDP and TCP runs on the top of the IP, and sometimes referred to the UDP by IP, TCP by IP. Both protocols are send short packets of data called datagrams. And how this TCP versus UDP done? Within a TCP, we have our messaging system. Like when we send the data, it is SYN, then acknowledgement is sent, and finally accordingly sent to the receiver. Here, the only request response model is followed, and this is what a UDP is all about. This is connection oriented, and this is connectionless. This is the main difference we are depicting in the figure. So UDP is a connectionless protocol providing the data against services. UDP is less reliable because there is no guarantee that the UDP datagram ever reaches to the intended destination, or it reaches its destination only once. In the same condition, it was passed to the sending UDP layer by the UDP application. Okay, and this is all about this layer, this TCP, UDP, and IP layer, and IP ICMP is also there. This is all about this network layer and transport layer. Now we will study some this application layer. We have studied FTP. So we have now idea of how the data is this idea, how the data is sent from the IP to the UDP and the TCP UDP, and this what is ping and trace route ICMP actually is focusing. Now we will understand more about some protocols which is occasionally used, but it is more nowadays it is helping in the whole process of the whole process of internet whole process of internet management very well. They are helping in a very well manner, like ARP. ARP is the address resolution protocol. It is used to mapping an internet protocol IP to a physical machine address that is recognized local network. Very important phenomenon. To physical end of the day, we are working with the physical machine, and we need a protocol which is at the local network, either in my network. It help in recognizing the data what I want to receive from center. So in the IP4 D4 networking layer, we uses actually this ARP to map an IP address into the hardware address. So major job of the ARP is to map an IP address into the hardware address. Okay. In the IP4 B phase 6 and the networking layer, the mapping is performed at the network neighborhood discovery ND function, or local area networks, such as address will be called as the media access controls, MAC address. ARP request form, source MAC IP, so target MAC, target IP. Like we have a source MAC, source IP, target MAC, target IP. And in response, we have a target IP, target MAC, source IP, and source MAC. So see how this request and response model of the ARP protocol is taking care. We have a source, we have target, we have source, we have target, and the MAC address as well. This MAC address is a physical layer address which is ARP is doing. It is mapping an IP address to the hardware address. What is RARP? And this reverse address resolution protocol is used to reverse the operation of the ARP protocol. It maps a hardware address to an IPv4 address. Note that both ARP packet and ARP packets are not forwarded in ARP packet, but are themselves media level packet. Okay. ARP and ARP are not used on all network type, or as some network type do not need these protocols. That's why I am saying so. Basic protocols are there. They are helping in process. ARP or ARP. They are helping in the process. If the ARP process is to map the internet to the map and IP address to the hardware address, so RARP is to map the hardware address to the internet address. This is what ARP are. RARP is on. Let's move towards the DNS. See, end of the day, every system has this IP. But to understand the human brain, to understand the humans, if we say that the system is 192.168.0.1, if we say that 192.168.0.2, it's not easy to remember the IP addresses according to this formulation. That's why DNS is created. And for managing this, we have our DNS server. DNS is internet domain name which is translated to the IP addresses. DNS map the name, easy to understand to the people, to the IP address of the computer. This is what the DNS is all about. Okay, this is simple. A DNS is all about. Like for example, if somebody has a techtarget.com website into a website, a server behind the scenes mapped to the IP address. This techtarget.com is actually is IP address 206.19.49.14. What is DSCP? DSCP is Dynamic Host Configuration Protocol. It is used to provide quick, automatic and central management for the distribution of IP addresses within a network. DSCP is a Dynamic Host Configuration Protocol. It enhances the process of IP address. Okay, it used for the quick, automatic and central management of the distribution of IP addresses within a network. DSCP is used to configure the proper subnet ones. Very important. Default gateway. Very important. And DNS server information on the device. Very important. So these DSCP add the availability of IP. How? With the help of DSCP server, IP addresses create a subnet and IP routing system from which IP address is dynamically allocated to the various client. Okay, this is a job of the DSCP protocol, which is known as the Dynamic Host Configuration Protocol. And this is up to the internet layer, and we are talking about these layers. We are talking about these layers actually. Network interface layers, network layers, and transport layer. Now we will talk about this application layer, HTTP. We are talking about FTP, HTTP, and its property as well. So let's understand this. This from this way only thing is going on. Let's understand this HTTP, HTTPS, SSL, PPP, POP3, IMAP, SMTP. These things and revision of protocol need extra time to really enhance the TCP IP UDP protocol. Levels learn is the better one. So I think we should continue for the next lecture within this domain and understand in a more elaborative way to make the path of the web technology more easy. Thank you for your patience learning, and we will connect with the next lecture on the same topic. Thank you very much.